All right, we are back. Video number 2 for the final 2 skills. And then after this, you're ready to tackle the homework. So let's dive right in. Skill number 3. We're going to talk about the domain of a function. We're going to save range for another day. So we're just going to talk about domain. And a little recap of what domain is. It has to do with what we've already talked about. It has to do with what can go into your function. What type of inputs you can have. What type of numbers can work when you get plugged into a function. Like here's what I mean. If you just have, well, let me stick with function notation. If you have f of x equals 3x, like if that's your function, just a basic linear function, is there any value that we can plug in to that x value that will give us like an undefined or an imaginary number? And the answer is no. We can put negative a million, it'll work. We can put 0.2, it'll work. We can put 53,000, it'll work. Literally, when you're talking about domain for this, the domain would be negative infinity to positive infinity. Everything works. Okay? But there are 2 special things we have to hunt for that will not work. And that's what we're going to focus on. Literally everything works. So what you do, all you need to do to remember is the 2 instances where something doesn't work, and then you're set. Okay? What 2 things do we explicitly look for to exclude from our domain? Here are the things we have to avoid. We have to avoid negative numbers under a radical. Remember, a radical is like a square root. So we do not want negatives underneath a radical because that's an imaginary number, and we do not want to include those in our domain. So that's the first thing we have to avoid. And the second thing we have to avoid is we cannot divide by 0. So actually, I want to phrase it like this. We want to avoid 0 in the denominator. We want to avoid negative numbers under a radical, and we want to avoid 0 in the denominator. Okay? And I think the best way is to let me talk through these 2 examples. Determine the domain of the following functions. Write your answers in interval notation. That's brackets and parentheses and whatnot. Okay? So when I look at example 5, f of x equals 4x squared minus 3. I'm hoping you're familiar with what this looks like. I think it really helps to picture it sometimes. And an x squared graph, remember, looks like a kind of a parabola. Okay? There are no breaks, there are no gaps, there are no asymptotes. And so, spoiler alert, this domain is going to include every number. Because do you see an instance where we would divide by 0 here? We can't, because there's no fraction. Like if this was all over x or something like that, then yeah, we'd have to be careful. Do you see an instance where we're going to have a negative underneath the square root here? I hope not, because there's no square root for that to happen. So both of these are good here. So if you know that they're good, then you can say that the domain is going to include all real numbers. There is nothing to exclude from that domain. Everything works. You can plug everything in. Let me show you an example where everything doesn't work. That's example number 6. Okay. I don't see any square roots, so we don't have to worry about that. But we do have a denominator here. And we do not want this denominator to be equal to 0. So it's pretty actually self-intuitive what we do. If we don't want it to equal 0, then what we need to do is we need to take it and set it equal to 0 and solve for what we don't want x to be. We do not want x to be negative 1, because what happens if we took a negative 1 and we plugged it in right there? You would get 0 in the denominator and you would get an undefined value. So basically, this right here is the one number that does not work in our domain. Okay, So what we would say then is we would say that the domain for this function is literally negative infinity all the way up to -1, but you skip over -1 and then go to positive infinity. It's literally every number but -1. Okay? I strongly encourage you, if you want to watch that again, now that you've heard it once, and hear me talk about how you find what you need to exclude. We want to avoid having 0 in the denominator, and so that determines that. I wish there was one more example, so I'm just going to throw one right in the middle and show you what I mean about the negative numbers under the square root. If we had this, I'll pick a very basic one. If we had a function that was like 2x plus 5, something like that, we cannot have negatives in the radical. So what we do, check this out. We take what's under the radical and we say that we want it to be greater than or equal to 0. You see what I'm saying? Greater than 0 means positive. We want it to be positive. So then I solve this really quick. I subtract the 5 over, and I have 2x is greater than or equal to 5. I divide by 2x. Sorry. When you subtract that 5 over, it's a -5. I divide by 2, and I get -5 over 2. We need x to be greater than -5/2. Because if we plug in something that's less than that, like 5/2 is 2.5. So watch what happens if we put a -3 in here. Imagine if we put a -3. 2 times -3 is -6. -6 plus 5 is -1. That's an imaginary. Okay, so we need our domain to be this. So how would we write that? We would say that our domain needs to be greater than -5/2. So we would use a bracket and say it needs to be -5/2 and bigger. That would be our domain for this. I hope that is helpful. When on the homework, it asks you to determine what you need to exclude from the domain. That's what it's talking about. Look for places where you might have to get 0 in the denominator. We don't want that, so you avoid that. And you avoid negatives under the square root. All right, skill number 4. You do this so much in calculus, and we'll do it a lot here. Because it matters in the real world. That's why. You want to know when a function equals 0. If you're modeling something being like shot through the air, then when it hits 0 is important because that's when it hits the ground. If you're a business, you would want to know, and you're trying to graph your profit, you would want to know when it hits 0. That's pretty important because you no longer have a business. So that is a key thing. And then also, another key strategy used in a lot of problems is finding when one function is equal to another. That's huge in business. You're comparing two products, right? Like imagine if like here the blue line represents like AT&T's profits and like the green line represents Verizon's. It's like you need to graph this so you can see when their profits are equal, then maybe when AT&T surpassed Verizon, etc., etc. So comparing two functions and finding when they're equal is pretty important as well. So when you're looking for values of x so that a function is equal to 0, you set the function equal to 0 and solve for x like you normally would. And when you're looking for values when one function is equal to another function, you set them equal to each other and solve for x. Okay, so if you want to know when something's equal to 0, set it equal to 0 and solve using your algebra skills. And if you want to know when two functions are equal to one another, set them equal to one another and solve for x using your algebra skills. So let's bounce around here because I have to have this done in 4 minutes, so I might not do all of these. Find all real values of x when something is equal to 0. Let's do the first two. So I want to know when this function is equal to 0, so I literally set this function equal to 0, and then I use some algebra. I add 3 to both sides. Now I'm here. Divide both sides by 4. So now I'm here. That's x squared, so I need to square root. So boom, boom. And I get x equals plus or minus the square root of 3 over 2. Shout out to the unit circle. Coming back. Those are the two values where it would be equal to 0. If you don't believe me, plug it in. I promise you. We just solved it. The algebra don't lie. Okay? And then on this one, when is it equal to 0? Well, I'll do the same thing. I set this equal to 0. X squared minus 1 over x plus 1. And you want to know something cool? I'm hoping this will click. I bet it clicks with half of you. And the other half are like, what is Smith talking about? When you're wondering what makes a fraction equal to 0, you don't even look at the bottom. Because think about it. If I have like a 12 on the bottom, if I put a 0 on the top, it instantly becomes equal to 0. So all that matters in fractions when you're trying to get it equal to 0 is the top. So what I would recommend you do is you just need to find when is the top equal to 0, and you will officially have your answers. So what do we do? X squared minus 1, that turns into x plus 1, x minus 1, a little factoring action. And so our two answers are x is negative 1 and x is positive 1. Those are the two instances when that function is equal to 0. All right. Uno más. Find all values of x such that f of x is equal to g of x. Fancy math lingo. It's just saying, tell me the answer, tell me the x value where f and g meet. That's all it's looking for. So how do we find that? We literally set up equation. And if f of x is x squared and g of x is x plus 6, let's set x squared equal to x plus 6, solve using algebra, and we will find our answer of when they connect. Okay? So how do you solve that, Smith? One's an x squared, one's an x. Shout out to last semester. You need to get everything on one side and factor. Factoring is huge in solving equations. So I'm going to leave this x squared over here on the left because it's positive. I like it positive. I'm going to subtract x over. I'm going to subtract 6 over. So that is my new equation. How do I solve? A little guess and check. Factoring will never leave you. X and x, 3 and 2, minus and plus. So my two answers are 3 and negative 2. So you're telling me these touch at 2 spots, Smith? We got 2 answers? You are correct. I'm going to prove it to you really quick because this will be super easy. X squared and x plus 6, they have 2 answers. Take a look. If we go to y equals and we do x squared, and then we do x plus 6, they should intersect at 2 spots. Oh, that was fast. Negative 2 and 3. Booyah. Okay, graphical proof. I'm just a beast. I want to roll. So there's our 2 answers. And last problem of the day before you work on homework. When is f of x equal to g of x? Well, let's go ahead and say, when is this equal to that? And once again, it looks like we got another factoring problem. So very similar. I'm going to bring the 8x over here because I like my first number to be positive. And I'm going to bring the 15. So I got everything to the left. I officially moved it all to the left. And now it's just a matter of guess and check. Ooh, this will be tough. Am I ready for this? Put me on the spot. Factors of 8 and 15. Well, let's just do what I tell you. I always say try the middle ones. Let's see. 15, that'd be 3 and 5. So if we put a 3 here, that's 12. And then put a 5 here. Oh, look at me. It's a freaking, this is a snow day. This is just the stars are aligning. I need to make it a negative 2. So let's make that a negative and that a plus. And let's do a quick check on my math. That's 8x. That's negative 12 and positive 10. Booyah, it works. So our 2 answers are x is equal to negative 5/4 and x is equal to 3/2. Bada boom, bada bing. Those are the 2 values in which these are equal. If you don't believe me, whip out your